today we're going to do a real brief overview. We're going to do a real brief overview of compounds. Okay, we're going to try it the way that I normally give notes tonight, and see if this isn't a little bit better, or if it's worse, or what it is. We'll see. Okay, compounds. Now, if you look around your room right now, or wherever you're at watching this video, how many different kinds of substances do you see around you? 10, 20, 100, 1,000, lots and lots of different kinds of materials, just in the close proximity of where you are watching this video. So if we have (92) naturally occurring elements on this planet, and you're looking around at all kinds of stuff, more than 92 different kinds of stuff, how can that be when there are, fundamentally only 92 different kinds of atoms? Well, the reason a meager 100 elements can make an abundance of different substances is the ability of atoms to bond together with other atoms to form a compound that has unique properties different than the atoms that make up the compounds. So for instance, and we're just going to see how this works here. We have water. Okay, so what elements are water made of? Well, water is made from hydrogen gas and oxygen gas. And let's balance this thing so that we don't have any problems here. We're going to need a 2, and we're going to need a 2. Okay, so hydrogen and oxygen can combine together to form water. Okay, water is a compound. It's made up of 2 or more atoms. Oxygen is flammable. Hydrogen is explosive. But we can actually use water to put out this flame, right, of a combustible oxygen reaction. And so water is not explosive. It is not flammable, but it is made up of elements that are. So once atoms bind together to form a compound has got unique properties, different properties than the elements that make it up. All right, so we call the force, so force of attraction, we call the force that holds atoms together in compounds a chemical bond. And there are 3 basic types of chemical bonds. A metallic bond forms between atoms of metals. And in a metallic bond, the electrons are free to flow from one atom to another atom to another atom. We're going to talk a lot more about bonding in February at much greater depth. So really, we need to keep in mind that this is just a quick overview because it's going to help us in what we're going to do next, and that is naming different compounds. Okay, so metallic bond forms between atoms of metals. The electrons are free to flow from atom to atom to atom in a metallic bond. Okay, so I'm saying to you, a metallic bond forms between two atoms that are metals. Okay, how do we know which atoms are metals? Well, I'm going to go into your planner, and in your planner, there is a periodic table of the elements. And it's nice because in the planner, things are color-coded. Okay, we're going to do this. You can always use your planner periodic table, but we're going to do this in class as well with your with the periodic table that I gave you. Okay, so everything that is in gray are metals. These are the semi-metals in chartreuse, or the metalloids. And then shaded in blue are all of the non-metals. What are some characteristics of metals? Well, metals are generally solid, except for with one exception here at room temperature, and that's mercury. So they're solid, they're shiny, they are malleable and ductile, and that means that they can be pounded without breaking, and so they're not brittle. And ductile means that they can be stretched without breaking as well, so we can form them into very long strings. Okay. And we're going to keep it very superficial. So, there we go. Here are the metals. If we've got one metal bonded to another metal, we say that the type of bond that's holding that together is a metallic bond. And in a metallic bond, valence electrons are free to flow from atom to atom to atom. Okay. A covalent bond. Extremely simplistic, you guys. Let's keep this in mind, the way that I'm presenting this right now. A covalent bond is formed by two nonmetals that are sharing electrons. And we say that if two nonmetals are bound together, and they are bound together by a covalent bond, and this forms a molecule. So by definition, things that are held together by a covalent bond are called a molecule. An example of that is carbon monoxide. Okay, so how do I know that carbon monoxide is held together by a covalent bond? Well, what I would do is I would go to my periodic table, and here's carbon, and here's oxygen, and they both are color-coded blue, meaning that they're nonmetals. And so if it's a nonmetal bound to a nonmetal, we know that it's held together. The force of attraction that holds those two atoms together to form a compound is covalent. Okay. And finally, we have an ionic bond. And an ionic bond results from the attractions among oppositely charged ions. We don't know what an ion is yet. We will tomorrow, but we don't know that yet. So don't worry about that. What you need to remember right now, the most important thing for you to get out of this, is that an ionic bond occurs between a metal and a nonmetal. And we call that kind of compound a salt. So not just sodium chloride, which is table salt, which we eat with food, but also potassium chloride or any metal bonded to a nonmetal. Okay, so any metal bound to a nonmetal and we say that those two are held together by an ionic bond. Okay, let's not talk about the metalloids right now. We will, but we're not going to right now, because it depends, really. And once you guys get a little bit of, expertise and experience at this, you're going to be able to make the judgment for yourself as to whether that is an ionic bond, a covalent bond. So we're just going to leave that alone for right now. Okay. Then, finally, compounds can be represented in various different ways. So, we represent them with chemical formulas, structural formulas, or three-dimensional models. So, for instance, let's see, what do I have here? Yeah. I've got this. Okay, so this is the chemical formula for water, H2O. And what does that chemical formula tell us? Well, that chemical formula tells us that we've got one atom of oxygen and we have 2 atoms of hydrogen. So the subscripts tell us in a chemical formula how many of that type of atom we find in the compound. So H2O, 1 atom of oxygen, 2 atoms of hydrogen. A structural formula, which is this right here, also tells us what kind and how many of a particular kind of atom we find in a compound. But it tells us something else too, and it tells us the way that they are connected together. So a structural formula gives us a little bit more information. It tells us that the oxygen is in the middle, and then coming off of this central oxygen, we have what we call ligands, okay? They're hydrogen. So oxygen is the central atom, and coming off, we've got a hydrogen and a hydrogen. So notice, you guys, we don't have an oxygen and a hydrogen connected to a hydrogen. This is the way the actual molecule looks, with the oxygen in the center. Okay, so a structural formula tells us the way that things are connected. And then finally, we have three-dimensional models. All right, and this is an example of a three-dimensional model of water. Okay, so here's the oxygen, and these two are hydrogens. Now, the beauty of a three-dimensional model is it gives us all the information of a chemical formula. So it tells us, well, we would have to know the color code, that the black stands for oxygen and the reds are hydrogen. So it can tell us how many and what kind of atoms we've got. It also shows us the same kind of information that a structural formula does, in that it tells us how they're connected to each other. But it also goes one step further, and it shows us an overall shape of the molecule or of the compound. Okay, so you guys, we're going to go back over this a lot. This is very, very, very superficial here. Okay, so we're just trying to get some common vocabulary is what we're trying to do. All right, so again, force of attraction that holds atoms together to form compounds. We call that a chemical bond. Chemical bond is a force of attraction. And there are 3 basic types. There's a metallic bond, and we know that something's being held together by a metallic bond if it's 2 metals that are bound together. A covalent bond are 2 or more nonmetals, and they are sharing electrons. And an ionic bond is a metal and a nonmetal, and that arises from oppositely charged ions. All right, and that is going to do it for today.